So good morning, and in today's video, I wanted to talk a little bit about ions and ionic compounds. So the first thing we need to talk about are ions. And basically, we've talked about atoms, and atoms are what can become ions. And so we talked about that atoms are defined by their number of protons. And we've talked about how in a neutral atom, the number of electrons is the same as the number of protons. But that's not the case with ions. Ions are where you have a different number of electrons than you do protons. And you might say, well, why would that be? What type of situation would that happen in? And the thing is that many atoms are unstable. And they don't like that. They don't like being unstable. They want to be stable. And so most of the time when you see atoms that we've been looking at on the periodic table, they're not by themselves unless they're a noble gas. They want to grab on to something else. And so noble gases, those that are on the far right of the periodic table that have those full shells, they have full energy levels, they have all of those full, they're cool, they're stable, they're inert, they don't react with things. But most of the other atoms they do react with things, and because they want to be stable. And by forming ions, that allows them to kind of become stable. And so they don't change the number of protons. So it's still, chlorine, but it will change the number of electrons so it can become stable. So let's use chlorine as an example. So I have chlorine, and I find that on the periodic table, it's in group 7. So I know it has 7 valence electrons. So let me go ahead and draw those electrons using the Lewis structure. Okay, so I have my, and I knew that because it was in group 7 on the periodic table. And it's unstable. So it wants to become more stable. And so it kind of wants to become a noble gas. Everybody wants to be a noble, all of those want to move over to that side. And they want to do that in the easiest way possible. And it's much easier for chlorine to gain 1 electron than it would be for it to lose 7. So it's kind of, like everybody else, like middle school student, like adults, it wants to take the easiest path possible. So the easiest path possible is for that to gain 1 electron. Now remember, electrons are negatively charged. So when I'm gaining a negative, I'm going to become more negative. So that then forms a chlorine ion. And if I were to draw the Lewis structure of that, it now has gained 1 more electron. So it is now stable. It has all of that entire energy level is filled with 8. And so it's cool. It's stable. It's now an ion, and it has a negative charge. And it's an ion because it has more electrons than it does protons. So that's a bad way of saying it. So a better way for me to say that would be the number of electrons is different than the number of protons, because you can lose electrons too, if you are, say, a metal versus a non-metal. So let's actually talk about that. So if I have a metal, and I want to use black here. So if I have a metal, what I already know about that is that would be a element from the left side of the periodic table. And when those form ions, they want to give away their electrons. And so they're going to form a positive, what's called a cation. Okay. And a lot of times those are going to then bond with a nonmetal. And that nonmetal often wants to gain electrons. And when they gain electrons, they form negative anions. And then the result of those two bonding together is an ionic compound. Because remember, a compound is a molecule that is made up of two or more elements that have bonded together. And so, I always like using examples. So let's go ahead and do an example, and let's stick with chlorine that we've been using. So chlorine, as I mentioned, was a non-metal, and it's going to want to gain an electron. So I'm going to put it over here, and that will be my example then of a non-metal. And one of it likes to bond with quite a bit would be, say, sodium on that side. Okay. And when I look at sodium, sodium forms a +1 or 1+ cation. Chlorine, as we already said, forms a -1 anion. So when those bond together, they're going to form, sodium chloride. And that's basically table salt. So that sodium chloride would be a ionic compound, and it forms kind of this crystal lattice. And so I'm going to kind of try to draw that, in the best way I can here, is how those then are bound together on that. And I have an example of this on my desk if you wanted to see what that looks like, but that then would be a salt crystal. Okay, let's go ahead and do some other examples. Of some other ionic compounds. So again, the way that these form is I have a metal, and I'm going to bond that to a nonmetal. And then my result is going to be a compound. And so let's say I have aluminum, which is in the third group. So it's going to have 3 valence electrons, and it will want to give those 3 up in order to become stable. So when it gives up 3 electrons, it forms a 3+ cation. And then for my nonmetal, I'm going to go ahead and use fluorine. And so I'm going to combine those together. Now, fluorine is in the group 7, so it is only lacking 1 electron. So it wants to gain 1 electron. And in doing so, it becomes electronegative. So it forms a 1- anion. Now, the thing here is I need to make sure that when I form these compounds that my ionic charges are balanced. So I'm going to need 3 of those fluorines in order to balance out that one aluminum. And so my resulting ionic compound then is going to be 1 of the aluminum, but 3 of those fluorines. Okay. Let's do another example. This example is going to be magnesium, which has a 2+ charge. It wants to give up 2 electrons. And the nonmetal I want to use is going to be phosphorus. And that has a 3- charge. Now on this one's a little tougher. So on this one, there's kind of 2 ways I can go about it. I can look at it as, what is the lowest common denominator of 3 and 2, which would be 6. Okay, so in order to get a balanced compound, I would need to have, a neutral charge. And so, 3 goes into 6, 2 goes into 6. And so that would be one way of doing it. I actually think a simpler way is just doing this crisscross method. So what I do with that then is I go ahead and write out my elements, which would be magnesium and phosphorus, and then I just crisscross them. So the charge of one becomes the subscript of the other. So what that means is magnesium has a charge of 2, so I'm going to need 2 of the phosphoruses in order to balance that out. The phosphorus is 3, so I'm going to need 3 magnesiums to balance that out. So those kind of crisscross. So this goes over there, and this goes over here is how those kind of work out. So you can think about it as, lowest common denominators, or you can think about it as crisscross, whichever one works for you would be excellent. Okay. So again, I want to make sure that you understand why we're doing that. And we're doing that because that total ionic charge must equal 0. I don't want to have an ionic charge of that compound. That it's going to keep reacting until it gets a ionic charge of 0, and then it's completely stable. Okay. Again, as always, if you have any questions or any comments, please just contact me and I'll help you any way I can.